All right, we're going to try to crank out 2 days in one day. That's going to be fun. Oh. Advent of Code 2024, day 15. Warehouse Woes. He's going for a lot of the alliterations here. You appear back inside your own mini submarine. Each historian drives their mini submarine in a different direction. Maybe the chief has his own submarine down here as well. You look up to see a vast school of lanternfish. Oh, I remember those. Swimming past you. On closer inspection, they seem quite anxious, so you drive your mini submarine over to see if you can help. Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. These lanternfish seem so anxious because they've lost control of the robot that operates one of their most important warehouses. It's currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could shut it off. However, if you could anticipate the robot's movements, maybe they could find a safe option. The lanternfish already have a map of the warehouse and a list of the movements the robot will attempt to make. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. Okay, so we got a maze here. The robot is an @ sign. The boxes are O. So this is like Sokoban. If there are any boxes in the way, robot will attempt to push the boxes. If it would cause a robot or box to move to wall, nothing moves, right? Initial positions are shown. Rest of the document describes the moves. We've got up, down, left, and right. New lines within the move sequence should be ignored. Okay. So we have initial state. We move left, can't do that. Move up, we can. We move up, we can't do that. Right, we can. Okay, so that was one of the things I was thinking. Does it move boxes that are against other boxes? And the answer is yes. So we're able to move both of them right. And here I'm able to move all 4 down. Okay, that's a good thing to know. The larger example has many more moves, and it has this as the final position. Okay, so what's the output? Oh, right here. GPS coordinate, the goods positioning system. Okay. Okay, so it's 100 times the row plus the column. And what's the sum of all of those? All right. Get input 2024 15. Oh. Ooh, I might not. Yeah, I'm not logged in. It logged me out, didn't it? When I hit refresh on this page before I started streaming, it logged me out. So I'm guessing whatever timer I'm using timed out. So, okay, I'll have to get a session key, but I'm not going to do that on stream. So let's just do it this way. Save as 2024, day 15.txt. Wow, that's a lot of motion. All right, and then we're also going to get some test input. Downloads 2024-15 to input. And then we'll have the quote-unquote larger example. Cat test 15-1. Okay. So we're creating a grid. We're going to store boxes and walls in the grid, and everything else is just going to be open space. We're also going to need a robot position. So robot. And then a warehouse. Oh, I probably should just make, yeah. Warehouse struct. And this will contain the rows, calls, and the floor, which is going to be a hash map from position to item, let's call it. It's going to be a box or a wall. Let's do it this way, and then we can, that way we can impl from stir for, oh, no. All right, we'll just do it the normal way. Let lines equals AOC lib read lines 2024 15 text. Now the thing is, we need to separate out the map from the moves. So let's call this moves, which is going to be a vec of char. It said new lines should be ignored, so we'll just combine them all into one list of moves. It seems like the easiest approach. Here's my problem now, is that I normally get the rows and cols from the size of the grid, but we have to change this. Read line strips out blank lines. So I probably should change that up, but I haven't. So we're going to do this. Let mut row equals 0, while lines of row starts with, because they all start with the hash. Then we're going to add it to the grid. So we're going to say self where, oh, for call in, no, call ch in lines row iter, oh, chars enumerate. If ch is equal to this, then we're going to self warehouse insert and we're going to say item wall. Else if ch is equal to a box, self warehouse insert item box. That was weird. I don't know why pretzel hung like that. Else if I should probably use a match, right? If it's the robot, then we're going to store the robot position. And we ignore everything else. Row plus equals 1. And then when we're done, I guess what we could do, we can say self rows is equal to row as I64. Self calls equals line 0 len, line 64. We can still do that. And then I can print out, make a display for warehouse. Move that there. Impl display for warehouse. Oh, no code action available. What did I do wrong? Oh, because I don't have hash map. Can I do it now? No? This is weird. Oh, that's why. Because I typoed it. I was going nuts. For row in 0 dot dot self rows. For call in 0 dot dot self calls. Right bang f. Oh no, we can say match self warehouse get row call. Why did that not? And then OK comes down here. Oh, thank you, Scoops. Now I understand what you mean. And I do need to make it default. Oh, okay. No debug. I can live with that. self warehouse floor get. Oh, this already is a okay. So if it's none, we're going to write a dot. If it's some item, I'm going to write item. Oh, right. And then we're going to impl display for item. We can do this again and have it write some of the code for us. Right, bang, box is O. And this is a hash. Oh, we don't even need to do that. Yeah. Unknown field? Oh, because it's on the warehouse. Okay. Let's see if we can print out the warehouse using the test data that I just created. Println. Oops, I forgot the new lines. Okay, and that looks right, hopefully. Yes. Okay, and now we'll grab the moves. The moves should be let moves, oh, sorry, self moves is equal to lines row dot dot iter. So we just collect into a string. Oh, collect into vector characters. Actually, I shouldn't even need to tell it. So moves is a vector character, right? Oh, I have to say iter chars. I probably have to say flat map line chars. Collect. Thanks, Scoops. And I still need to tell it this needs to be a vec of chars. I probably should make a vec of moves, right? I should have, if I have the box moves thing, that's fine. All right, so now I think we have all the data we need to do part one. I guess that's right. For move, oh, I can't use move. M in self moves. How do we want to do this? We want to check to see if the robot can move in a specific direction. And we need to tell if it can by looking that way. And if there's a space, we just move. And if there's a box, we have to check beyond the box. Okay. Maybe I do convert these things. Char to direction. Oops, I64, match CH. And then we'll have up. So what I'll do is I'll collect these values into the moves array. left is going to be 0, 0, -1, and right is going to be 0, 1, and everything else is panic, invalid, move, ch. Right, and we're not using it, but we can do this, I64, I64. And then here, we'll say char's map, ch, char to direction, ch. Okay. Oh. Oh, interesting. Do I have to go beyond? Oh, I forgot to increment. Oh, no, I just put this in the wrong spot. That's got to be after the loop. There we go. I wonder how I messed that up. That's weird. Yeah, okay, so now we have a bunch of moves. I'm gonna assume they're correct. So we're gonna say for m in moves, we're gonna say I'm gonna write a function called canMove, which is gonna check if you can move from A to B. So our current position is going to be the robot position. Plus M0, self robot 1 plus M1. And this is our new position. Oops, M.1. Yep, okay, that's better. And now if we can move, let's say self warehouse can move to new position, then we'll just move. And this will take care of doing all the motion for the boxes. Because I think I could just do that recursively. That's going to be my approach. Scoop says self moves extend. Oh yeah. Okay. All right. Let me get this. Can move will need the move direction as well. You're correct. Okay. If we can, then we're going to say self robot equals new pause. And then the output is what? Oh, right. 100 times the rows plus the calls. So we need to get all the box locations. Self warehouse iter filter map item. If item is equal to item box, then it's going to be some. Oh, wait, warehouse is a hash map. I don't know why it says unknown, which means this item should be the position and the item. So it should be some pos 0 times 100 plus pos 1. Else none. Sum I64. Will that work? I have a mismatched something here. Oh, I need a second one of these guys. There we go. So does this work now? No, it still says unknown. It's a warehouse. Okay, what am I missing here? Unclosed delimiter. Right. Can move is not found in warehouse. Oh, warehouse. Oh, you can't iterate the hash map? Oh, floor. Again. I gotta maybe put this on the warehouse itself. And then can move. So let's write that. If, let's say match new pos. If it's none, then we're going to return true, saying we can move there. Whoever called me can move to where they want to move. If it's some item wall, then we're going to return false, saying we can't move. And the only other one is a some item box. And that would require us to return can move. Well, first we have to calculate the next position. Let's just call this position. Well, 0 plus, and call this dir. Pos 1 plus dir 1. If can move next pos, dir. Right. Okay. I'm getting there slowly. So let motion equals this. Return true, return false. Otherwise, we're going to figure out if we can move, because we're a box, right? So if we're a box, we need to know if we can move. And if we can move, then we'll move. And what we'll do is we'll say self floor remove pos self floor insert You can just do the move inside the match. Oh, yeah. You're right. So if can move here, right? Item box. And then return true. Oh, we need to save that. If, I guess we could do it this way. And if we come down here, it's false. There's the if again. I guess what we could do here is just put an else. And then get rid of these returns. Whoops. No? Oh. This was supposed to be get. This was supposed to be get. Self floor get pos. Okay, so that should fix those guys. Oh, and we got an answer, but that's the wrong answer. 10,092. It's supposed to be. Oh, it is. I didn't even look. Okay, I think we got it. The small example is 2028. Let's run the real thing. If it works on the large example or one example, it should work on this one, right? We got a number. That is. Hey, that's the right answer. All right, this is good. This went pretty well. I appreciate the help in chat. Otherwise, this would have taken a little longer. I'm thinking I want to move score down to warehouse because there's no reason to have it here. And it might be useful for part 2. So where's impl warehouse? FN score, self. So now we get rid of this, and we get rid of this, and we get rid of this. And put that there. There we go. And now I have to actually call it self warehouse score. Yep. All right. I think we're good. Let's check in with Clippy and then commit these. Oh, yeah, that's right. You can simplify these sort of things once you have it set up that way. Oh, and then of course you have to have the correct number of brackets. 57. Oh, M is already a reference. Okay. And then 112. Oh, I put a return there. And it looks like day 14 has some problems also. Oops. Oh, I know what's wrong here. All right, let me commit this change. I'll fix 14, and then we'll get on to part 2. Status git commit dash a. Oh, git add source git commit 2024 day 15 part 1. What am I missing here? Oh, this doesn't need to be this. Okay. Git commit dash am more clippy. Okay. I think we're ready. So what's part 2? The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Just as they start preparing a festival in your honor, reports start coming in that a second warehouse's robot is also malfunctioning. This warehouse's layout is surprisingly similar to the one you just helped. There's one key difference. Everything except the robot is twice as wide. The robot's list of movements doesn't change. Okay. To get the wider warehouse's map, start with your original map, and for each tile, make the following changes. If the tile is hash, it's double hash. If it's a box, it's a double box. An empty tile is 2 empty tiles, and a robot is on the left side of the pair. Okay. Oh, all right. All right, so how do we do a double warehouse? Okay, I don't know the best way to do this other than wide. And then extend item. So we have a box left and a box right. And then these two get this and get this. And now can move. I'm going to change this completely. So we're going to say everything else is panic. Wrong function for moves. And then wide is going to be self warehouse wide insert row as I64 call times 2 as I64 item wall and +1. And then we're going to do box left and box right here. Scoop says, I don't think you need to change it completely. I think it's just simple add 2 cases and done. Here's my concern. Okay. So so these things can shift one at a time. This is going up, so it shifts all 3 of them up. Yeah, here's the case I'm concerned about. We move up. So right now the way the code works is if we can move, we just move. Right? So we're saying, okay, take this box. I want to move this box up. Can I do it? Well, I have to check both sides. Here, if I check both sides, I see I can't move. So don't move. But if I come in here recursively, I don't know that this guy didn't move. He can move because it's empty, so this would just move it up. So here's what I'm thinking. This is going to be my approach. Left and right don't change. Left and right are going to be the same. If you can move, just move. But up and down, we're going to generate a list of all the candidate boxes that can move. And if one of them can't, then we abort the whole thing. If they all can, then we can move them all. And so we'll walk through the list of moves, the list of boxes that can move, and move them. So let's see how different this is. So part 2 is going to be almost this. But I'm going to call it can double move. And then score is going to have to check. Is it the same scoring method? Oh, yeah, it's just checking box left. Okay. So at least that part's easy. I need to be able to display it. Oh, I guess I can't do that now. Oh, maybe I can. Will that work? Because I've inserted 2. Yeah. Oh, except I'm only doing floor. There's no way to pass information to the display thing. If I change this to wide, let's see what wide looks like with the test data. Println self-warehouse. Oh yeah, I don't have can double move. Let's create it. And just return false for now. Oops. Oh, right, because this, for some reason, when it generates the function, it doesn't generate it with the references. Yeah, we're getting half the thing now. I have to do calls times 2. Where's my display? Here it is. Okay, so does this look right? Yeah, that looks right. Okay. Okay, so if we're moving left or right, which means direction dot 0 is 0. Then we can use the same logic we had before. A similar logic. Let's see, if it's a box left. Oh, and we just have to make sure we remove and insert it correctly. All right, this is gonna, oh, it's an option item. There should be something there, right? Else. And now we have to move up or down. I'll just put false here just to see if this thing compiles. Can double move. And we don't check floor anymore, we check wide. Oh, right. This needs to be mutable. Okay. Oh, yeah. So it's, oh, because I'm calling on part two, I'm calling can double move. How is it doing it? Uh-oh, we have a problem. It shouldn't come up with the same answer. Oh, it does because okay. I've already moved everything. Self let mutt warehouse equals self warehouse clone. Let mutt robot equals self robot. Right. We don't want to change it for part two. We're restarting from beginning. Oh, we can't clone warehouse. Oh, because item. Okay, good. I thought it maybe there's the hash map couldn't be cloned. Okay. Now I've broken part one. What did I break? Oh, I can't score it that way. That's right. It should still not, it should still only be, oh, you know what? I bet you what I'm doing is this. How come this isn't complaining about a missing? Oh, no, because of this. Okay. All right. Impl display. Let's switch this back. Right. And now we should be able to see it. It was supposed to be 10, what was it? 10.092. So it means we lost some things here. I mean, I still need to do this, right? And change this. But that's not the problem. I didn't even change this part. Git diff. Right, I'm still using the test input, right? I'm inserting onto the wide side of things. Part one. Yeah, I just changed it so it uses the local copy of the robot. I changed this for this, but that's not going to. And then I have this can double move. What? What broke? Well, let's print out the final position then. Okay, so everything is moving correctly. I'm just scoring it incorrectly. Oh, okay. Thank goodness. Okay, so part two, we started part two. We'll call this double score. So wide. Yeah, I'm not happy with the way this is all turning out. All this duplicated code. Okay. What's the score supposed to be for this one? 90-21. Okay. So can double move. We're going to return, we're going to say let is equal to self get move list on self position and dir. And it's going to say allowed and move list. And then if allowed, do the move list. We'll figure out how to do that in a second. And return allowed. And now we just need to write this. Oh. Huh. There. Okay. So we're assuming we're moving up and down. I'll say false. And this is going to be a vec of I64, I64. There's going to be a vec of all the okay. So we know that we're at position, and we want to move in direction dir. So let's say we're this box here. We're here, and we want to look up. Actually, what we can do is start by making sure that we're on the left side. And that way that should simplify the logic a bit. Let mut mpos equals pos. If some item box right is equal to self wide get mpos, then mpos is equal to mpos 0, mpos 1 minus 1. So now we're on a position where we have a left side box. And now we'll look in direction in both mpos 1 and mpos 1 plus 1 to see if it's free. If it's free, if we have a none and a none, okay, let's try that. Match self wide get mpos and self wide get mpos 0, mpos 1 plus 1. If it's none, none, we want to return true and the position we're in. If either one is a wall, then we're going to say return false and an empty vec. So far, so good. Oops, I put this here in the wrong spot. Okay. Yep, and we haven't. Oh, really? Okay, do I have to put an ampersand there? Yeah, and now we have a non-exhaustive list. Okay. We're going to have a left side and a right side. Oh, no, that's right. We need to check the position. All right. Let new pos is equal to mpos 0 plus dir 0. That's what we're going to be checking here. Okay. All right. And we definitely want this to be mpos because we're returning a list of items that can move. And this is the end of the tree. So now we can check left. Left is going to be an option item. So we can say match left. If left is a none, we could have a situation where we have ... open, close, and then we have this. All right, and we're trying to move this up. So left is a none, which means it's okay to move this. But we have to check the right side first before we can allow it. If it's like this, if it's some item box right, then we actually have to check this guy here. So it'll be get move list of self get move list. So we just checked this. So it's going to be new pause 0, comma, new pause 1 minus 1 in the direction we're going. And if it's some item box left, that means we have a situation like this. We just found a left one. So we want to return self get move list of new pause. I probably have to put an ampersand here and dir. Otherwise, we know it can't be a wall because we came through here. So this should be unreachable. All right, and then we have a Boolean and a vector of moves. We want to start off with move list is vec mpos. And then we can say if not motion, return false. It doesn't matter what that is, because as soon as we hit a false, we're going to stop completely. Then we have to check the right side, which is going to be something similar to this. So we got a situation here where we got a few dots and a block, and a few dots and a block like this. So we're checking the right side. If it is a left bracket, we're looking up above this. If this is a left, then we want to do that. If it's a right, it should have already been covered from up above. So we can ignore it. If it's done, then we ignore it. We don't want to do this here because we're going to do move list extend v. And then if not motion, return false v. Otherwise, move list extend v and return true move list. Is that everything? It doesn't like this. Oh, yeah. non-exhaustive patterns. Let me make this a little wider. Arguments to this are incorrect. Line 195, let's start with that. Oh, does this need to be reference? What is pause? Pause is already a reference. Oh, it's supposed to be a reference here. Consider borrowing here. I don't want to borrow. Oh, because I want to do that. Okay. Oh, okay. It's almost there. Move list is not used. Right. So if we're allowed, then we have a bunch of boxes we need to move that are movable. But we need to make sure we can move them first. So we have to work our way through the list while move list is not empty. We're going to find a move because we don't know what order they're in. Ooh, and I wonder if it can find duplicates. It probably can, because if you have a tree like this, and then this, and then this, we're going to find this box twice. Once up this way and once up this way. So we need to collect them into a hash set to uniquify them. And I don't have hash set, right? Yeah. Okay. All right. So while the move list is empty, we're going to collect all the moves together. We're going to process this. So we're going to say for m in, we'll call this a move set. Move set. Move list. Oh, you know what we should do is move list drain here, because then I can put things back on the move list. All right, so we're going to see if we can move this thing in the direction we're trying to move to. So we have the position of the left box. So we have to say let P1 is equal to M0 plus dir0, comma M1 plus dir1. And P1 is equal to this plus 1. These are the two positions we need to check, and they both need to be none. If self-wide contains P1 or self-wide contains P2, then we can't move. So we'll say move list push M. Otherwise, we're going to move the box. Oh, I missed an angle bracket here. There. How's that? Oh, contains key. All right. It's not mutable. Let's make it mutable. All right. That builds. Oh, no, it's computing. Stop computing. Oops. Okay. If it doesn't contain anything, then we can move the item that we're trying to move, the box we're moving. So we're going to say self-wide remove. And we know it's going to be left-right because we always should be left side things. We're going to say assert EQ self-wide get M some item box left. So it should always be the left side box. So remove M, self-wide, remove M0, M1 plus 1, and then self-wide, insert P1, item box left, self-wide, insert P2, item box right. Item something something. Oh, ampersand. Item doesn't implement, probably debug. Yeah. Okay, now I'm going to try cargo run. Oops. It found a wall. Oops. We got a bug. That was probably this assert here, right? Yeah. Let's take that tiny example. Where is that? And we can work on this tiny example here. Test 15 tiny. And we can print out each step, move step by step. Test 15 tiny.text. Okay, so each step is going to get printed here. So can move, can double move. Here it is. So after each one, we're going to print it out. Move dir self-wide. Okay. Oh, right. So let result equals. Right, it's just self. Okay. So this is after the first move. I should print the robot too, right? If self, oh, we're not moving the robot in here. And we should be if we want to get this to work. All right. So for now, all right. If self robot equals row call, right bang F else. There's no, oh, there's no robot in the warehouse. I got to change all of this up because I'm liking my code less and less as this goes along. Oh, because I'm not initializing. All right. So it moved right successfully. What's the second? And then it needs to move down, and it couldn't move down for whatever reason. Oh, because I was assuming it was a box left. It shouldn't have to be. If the move list is empty, that means the robot is just moving itself, and we don't care. Yeah, so the move list should have been empty. Four, four. 1, 2, 3, 4. 1, 2, 3. Okay, that's wrong. That should have been the robot. All right, we have to look at get move list, figure out what's going on. We're moving down. It was able to shift the boxes over, so that's a good sign. Maybe I should print that out first. So we can see that. Oh no, it didn't work. Oh no, the robot's in the wrong spot. It's supposed to be here. How did that mess up? Oh, I know why. Self S robot. And now I have to create that field. Nope, not extracting to variable. There we go. So hopefully that will put the robot in the right spot. Ooh. So we only moved half the box. Okay, so we got to fix this. We saw a box right, and then we called can double move, and that should have been to the next position, and that would have been box left. So we moved box left, return true, and then we should have moved box right. Okay, let's see. Right? Huh. I'm confused about what just came out. I broke part one again. That's probably because the robot's in the wrong spot. All right, I'm not going to worry about part one. Oh no, I didn't break it. Okay. Looks like that's moving some. Oh yeah, some box left, some box right, some box left, some box right. Oh, it worked. It just didn't move the robot at the end of it. Ah, right, and that's part of part two. Here. Robot now at new pause. Println self warehouse. Okay, let's try that. All right. So it worked. So this was the end of this. Is that the first robot now at? Yes. Okay. So it's returning 4.9, saying move to 4.9. The robot's at 3.9, and it can move to 4.9. So that means we need to check to see if we're the robot. If I guess I'm assuming here that we're a box. So what I need to do is actually just if we're a robot, we need to check just that one location. Can we move there? Yeah, maybe we do that up here. So the left right stuff is working fine. So what we can do is say else match how about this? Else we're going to say let motion, here we go. Allowed move list is match map get. We need to get the new position. There. And this is going to have, if it's none, then we're going to just return true. It's the robot. Okay. If it's some item, we'll match on that. Match item. Whoop, we'll match on that. Match item. Item wall. This is just return false. Don't move the robot into a wall. If it's an item box, this should be invalid because we're on the double move thing. If it's item box left, then we'll get the move list at new pause. And the direction, if it's item box right, well, we'll shift it over by one. So we always work on the left side of the box. Get move list new pause 0, new pause 1 minus 1, enter. And that should cover all the cases. And then we handle everything. Okay, let's try that. Why did I call it map? Self-wide get. Okay, let's try that. All right, it did something. Yeah, it's not quite working. All right, so we shifted over. That worked. We went down. Oh, I see. It didn't quite do the thing that was supposed to do. Okay. So that's this state here. And we go down one. Oh, we're supposed to go down again. Why'd we go left? Let's say this. This is one of those advent of codes where I know what I need to do is just all the weird corner cases. Let's try that. So we can see each move. So we're moving down, right? And here again, we're moving down and somehow the robot ended up in the wrong spot. And so we called can double move. Oh, I'm passing in the new position that I want to go to. Okay, that's where I messed up. That's where I messed up. So it's already the new position. Okay, let's try again. Down, down, over. And then it died. with an infinite loop. Oh, it's in here. It found the move list of things it needs to move, but the move list is not working right. All right, let's debug the move list. Which is where? The move list is move list. We converted the set. And this is probably going to be the infinite loop here. It's going to check 3, 5, and 4, 6. Because it looks like, oh, I messed up something here because it needs to have all 3 items in the list. It can't move 4, 6 until both of these things move. Okay, so what did I miss? I need to include at the beginning. I do. I have the item that we want to move. Oh, do I need to shift this over? Yeah, I think I need to shift this over by 1. Yeah, that might be the problem. Yeah, now they all shifted up. That's good. Is this right? Looks like I know we were supposed to move up twice, right? Here, move up, move up. And this is a move up, and this is a move up, and the move list is empty. But now it says robot is 4, 6. Did I just not print that part out? Okay, maybe we have it. Let's try the larger example. I'm going to have to comment at all these print lines. Oops. We're going to just try it and see what happens with part the larger example. It prints the location it would move if we're allowed to move. Really? Shouldn't have done that. Okay, let's see what happens. 9021. That's right. Oh boy, oh boy, oh boy, oh boy. I'm excited. This is a bear. All right. It didn't crash, gave me an answer, and yes, okay, that's good. That's the right answer. Wow, that was a toughie. Figuring out all those things. 2024, day 15, part 1. Okay, we're going to dive right into 2016 because I got to get this one done too.